Now, in this segment of the chapter, you will see about some commercially important batteries or cells. Children, basically, battery is a group of cells. Battery is a group of cells, and no cells, as you know, cells is a smaller portion. So, cell is the unit. Cell is the unit of batteries. This is the basic point. Then we'll see about the classification. So, the types of cells. Children, actually, cells and battery, they are, commonly speaking, they are same. Technically, they are different, but we consider cell and battery as a both. Now, there are two types. First is, primary cells, and second is secondary cells. So, there are two types. Now, we'll see about the primary cells. So, as name indicates, primary. So, primary cells are the basic cells, and once they are exhausted, they cannot be used again and again. So, they are the electrochemical cell, children. They are electrochemical cells. All they, primary or secondary, they are electrochemical because there is the chemical reaction. In order to chemical reaction, electricity is produced. So, they are electrochemical cells which can be used only once and cannot be charged. They cannot be charged again and again. They cannot be charged for further use. Meaning is, once they are exhausted, they have lost. They have discarded. Now, primary cells, we will see the example. So, dry cell. Then we have mercury cells. Mercury cell. So, first we will say about the dry cell, children. So, dry cell, it is also called as Leclanche. Leclanche cell. Dry cell, it is also called as Leclanche cell, or more accurately, it is called as compact form of Leclanche cell. It is compact form of Leclanche cell. Now we will see about the construction and working of the dry cell. Now coming to construction of the dry cell. Actually, dry cell, it is made up of a zinc container. Zinc container. It is the zinc container or zinc vessel. And this zinc vessel, it acts as anode. It is anode. And here, children, in cells or batteries, electrochemical cells, here anode is negative. Now in the center, there is graphite rod. There is the graphite rod, and this graphite rod, it acts as cathode or positive. It acts as cathode or positive. Now this graphite rod, it is covered by a metal cap. There is a metal cap because graphite or carbon, it is brittle, it may break. So it is provided the cap. Just this is it. You will never find this. Why metal cap is used? Because graphite or carbon, it is brittle or it is susceptible to damage. It may break. So cell can be invested. So This is the point. Now you have to see it never touches to the bottom. There is always a distance between this and this. Now around this there is a paste of, around this there is a paste of manganese dioxide. There is a paste of MnO2. Here we will mark here paste of MnO2 and charcoal, or you can say carbon. And in this again or layer between this zinc vessel and this there is a paste of NH4Cl and little amount of zinc chloride. Between this vessel and this layer, let's differentiate it. So this is it. Now the layer is protected by a covering. There is a covering. There is a covering of coal tar. Coal tar. This is layer of coal tar. Coal tar. It is waste from the petrochemical refinery, and so it is very hard. Hard in the sense that it is able to hold these materials together. One point, and it fixes the position. It fixes the position of this carbon rod, and over it there is layer of either steel or hard plastic cover or steel, depending on the battery. Now last, around it there is protective covering. Around it there is again a protective covering. This protective covering of either steel or hard paper. It also depends on the type or the company. It depends on the type or the company. And so there is the point, and this is the construction. Now we'll see the working. Now children will see the working, how it works. So basically, anode here, anode is negative. Anode is negative, and in this there is the oxidation. Always there is oxidation. So it is made up of zinc vessel. So zinc solid or zinc, we may write down solid. So it remains as it is, and it forms the zinc ions, and here 2 electrons are lost. So this is the anodic reaction or reaction at anode. Now in the second portion, at cathode. So cathode is here plus. So why anode is negative? Because at anode there is the loss of electrons. Zinc is more reactive. Zinc loses electrons, and as a result the electrons are accumulated on this. As a result, you see on all the dry cells of batteries here, negative mark is written, and here there is a positive mark on the side. If it is a battery, so here there is the this on this there is the positive, here there is the negative. So if this is throughout the world. Now coming to the cathode. Now cathodic reaction takes place. So we have this MnO2, we have charcoal. So this MnO2, manganese dioxide solid. Then there is the ammonium, ammonium chloride, as it is in form of moist paste. So it will provide ammonium ions. Ammonium ions are provided. Then of course, if there is the oxidation here, so naturally there will be the reduction, and so electrons are there. Electrons are required, and as a result of this, there is the formation of complex compound. There is the formation of complex compound of this manganese hydroxide, complex compound, coordinate compound, and plus NH3 gas is released. And this is the reaction. Now coming to the cell potential. Cell potential or cell voltage, it is approximately, it is 1.5 volt. On the average, 1.3 to 1.5 depending on the condition. Now coming to the demerits of this cell. Demerits of this cell, as zinc chloride is being slightly acidic in nature, and so it corrodes the vessel. You might have seen the dry cells which use in torches or transistors. Dry cells, they lose moisture or their body is decomposed. So this is the point, and this is all about the construction and working of the dry cell. Now, next cell is mercury cell. Mercury cell or the button cell. Children, this is very much important because these cells, they are used nowadays in a large number of appliances like watches, the watches which are powered by the batteries, then the calculators, hearing aids, and lot many there, countless. And why they are called as button cells? Because they are just like button. You all have seen. That's why they are called as button cell. Now you see the construction. Now, as they are very much compact, so it is very difficult to see. But naturally, we will see how it is made. Actually, these mercury cells, they are enclosed in a steel jacket. So first you have to see that they are miniature. Miniature means minute. Miniature cells, and the cathode and anode are enclosed in steel or steel alloy jacket. Steel alloy jacket. Why? Because this makes it, very compact, and it prevents from the moving of the cathode and anode. Now anode, actually children, it is zinc mercury amalgam. We call zinc mercury amalgam. Amalgam means any metal when it is dissolved in mercury. Mercury has very high density, and when we keep any metal, then mercury has the capacity to absorb it. If by chance we have mercury, so put a small piece of any metal, so within few days it will be dissolved, and thus it is called as zinc mercury amalgam. So it is the liquid form. Now coming to cathode. So just I have seen they are miniature and it is very much difficult to handle, and so as a result it is enclosed in steel alloy jacket or a jacket of this conducting material. Now it is this cathode is mercury oxide, FgO and graphite. HgO and graphite paste. Now coming to electrolyte. So here children, it is so miniature, it is so minute that it is very much, microscopic rather. So this electrolyte, it is KOH and zinc oxide. You can imagine the compactness. You can imagine the compactness, that how much compact it is. Now next we will see how it works. Now at anode or simply anodic reaction, so we have zinc amalgam. So zinc is reactive, mercury it is non-reactive. So zinc, but we write down, it will take up hydroxide ion as it is the it is electrolyte. It is electrolyte. So at anode there is always the oxidation takes place at the anode, and so there is the formation of zinc oxide plus H2O, oxide plus H2O, and there is the liberation of 2 electrons. Now coming to cathode. So at cathode there is the reduction, and cathode it is very minute. So HgO plus H2O plus electrons, and there is the formation of HgL. Means mercury, it is also generated as it is from this HgO, and here there is the formation of hydroxide ions. So the hydroxide ions are there, and so hydroxide ions are consumed here. So as a result, coming to the net reaction, children. So net reaction is very much important point. Now children, net reaction means the overall reaction. Zinc mercury amalgam, it is from the anode. Then coming to HgO, solid you may mention liquid. Then there is the formation of zinc oxide. We have seen zinc oxide, and there is the mercury liquid. So this is the net reaction. Now children, very much important point about the mercury cells or button cells is that they are able to provide, this is a very important point, they have capacity to provide constant voltage throughout their lifetime. You might have seen in case of watches or calculators, as long as the cell is live, they are able to work continuously, and if any watch stops suddenly. This is a very special point. But why it is so? Answer is, it is because there is no change in ionic concentration. There is no change in ionic concentration of electrolytes. So there is no change in the ionic concentration of electrolytes, and as a result, ionic concentration of electrolytes. It is because there is no change in ionic concentration of electrolytes, and as a result, they are able to provide constant voltage throughout their lifetime. So this is all about the two types of primary cells we have to study.